Thanks very much, Bronwyn. So I don't have any slides. You can look at this, this lovely branding up here while I talk. When we were setting up the centre, we wanted to identify areas of economic importance to Australia that we felt robotic vision could make a difference to. And some of those are ones where we were already operating. Agriculture was a space in which the centre already had some traction and was talking to people about specific problems that that industry had. And likewise with some of the other industries. We also wanted to set ourselves some stretch goals, areas where we thought that we could make an impact, the robotic technologies could be transformational, but where there was little traction so far. And automation in construction is one such area. We're interested in building systems that can operate in unstructured environments. And a construction site has some structure to it, but it's classically unstructured, unlike the factory floor where cars are made by robots. As we've heard from other industries, it's an industry where there's a large labour force, it's an expensive labour force, there's a large unskilled component to that labour force as well. And there are issues such as safety, productivity, quality control, all of these things that affect a number of the other industries we've heard about already. And therefore, there's a potential for automation using the kind of sensing that we're developing in the centre to operate robots either autonomously or semi-autonomously in unstructured environments in ways that either help humans or replace unskilled labour. And this potential for automation is something we know already has been recognised by some of the players in the construction industry who are investing in research in automation in construction. We don't have a plan of action to say this is the product that we're going to build. What we want to get from industry is focus so that we can generate great science. We came into this because we want to do cool research, but we also want to do something that is beneficial, and we're looking for application areas that the industry believes are going to be helpful to them either in the short term or the longer term. And I can come up with lots and lots of ideas, and what we're looking for is feedback on those ideas. What's the right thing for us to pursue? What's the wrong thing for us to pursue? Whys and wherefore. So the sorts of things that we could offer in terms of either existing capability or research throughout the life of the centre are things like site monitoring, either with mobile cameras or with static cameras for either security or safety, looking for trip hazards, looking for people entering no-go areas, looking for people entering areas where there's machinery that they shouldn't be going into. So that's a sort of a static version. Then we can go to something more dynamic by looking at mapping over time. So perhaps repeated site visits, monitoring progress, checking it automatically against what the plans are. And Vision provides a really nice capability that some sensors, such as lasers, for example, you might go in and you might build a geometric map of that environment. Vision provides this extra rich information that can tell you not just what the geometry of the thing that you're building is or your immediate environment is, but what is where. You can identify things as well as just saying the shape of them. You can say that, well, this is an air conditioning duct or this is something else. So Vision adds an added richness. So we can build, you would have seen one of the themes is semantic vision. So we can add semantically meaningful concepts on top of geometry. So one of the other application areas that one could take into a construction site is augmented reality. You've already heard Tom talk about human-assisted robotics, or John was talking about the idea of surgeons being able to see stuff augmented by knowing exactly where a camera is and knowing what else is going on in the environment. So, for example, one could provide virtual views to an operator of a piece of machinery. I think we've all sort of stood round and watched about 6 workers stand round a big ditch, and there's some guy up holding 2 levers and someone else saying, no, down a bit, left a bit, right a bit. That's the kind of thing that could be replaced with smart vision, smart sensing and smart control of that machine, not replacing the humans completely, but taking away the unskilled part of the guy just saying left a bit, right a bit, but keeping the skill of the operator. I guess a fourth one would be autonomous navigation. We all know now about machines that can drive around in open-cut mine sites completely autonomously. A building site is a much less structured environment than in a mine. But with the sorts of capabilities that we will develop in this centre, we believe that we can recognise clear paths, we can recognise safe places to move. So you could, for example, take a load from one point to another point autonomously overnight. In a safe and effective manner. And then, so my final point, and then I'll stop talking. So things like visually guided or autonomous planning, and I think I've already touched on that with respect to the digger, but you could imagine the same sort of thing with a crane, where you are using a combination of force sensing and visual sensing to guide where a beam is going to be laid down. So instead of having a guy pushing the beam or saying left a bit, right a bit, you can actually do that autonomously using a robotic vision system. And so what we really want is to be able to understand what are the biggest gains, what's the most transformational thing that could happen, what are the easy wins, what things should we be concentrating on within the centre, and so that we can do not just some cool research and publish a bunch of papers, as Peter says, but so that we can make a difference and have an impact in that industry as well as the others. So, thank you.